All right, starting with problem 634. Use your theorems about parallel lines and angles formed with a third line to find the measures of the labeled angles below. Show each step you use and be sure to justify each one with an angle theorem from your Angle Relationships toolkit. Be sure to write down your reasoning in the order that you find the angles. Okay, so let's zoom in here. On A, they give us one angle, 123, and there's a few places I can think about starting. Maybe I'll think about angle B here. I notice here's my two parallel lines, and here is my transversal. So B is on the alternate side of the transversal from 123 and interior to those two parallel lines. So B is going to equal 123 because it is alternate interior angles are congruent if lines are parallel. Okay, so if B is 123, let's see, what else can we deduce? Let's see, A is across from B. It is vertical. So A is also going to equal 123 because vertical angles are congruent. All right, which leaves us C, and I see two different ways I could think about this. B and C together are same side interior angles, or C and 123 are supplementary. So C is going to equal 180 minus 123, which is going to be 57 degrees, because C and 123 are supplementary. Okay, let's take a look at B. All right, we start with angle 82 here. And let's see, 82 and F together are supplementary. So 180 minus 82 is 98 degrees. And we could just say supplementary angles. Okay, so once we know F, let's see, we have, here's our two lines that are parallel. Here's our transversal. All right, so if I slide F down the transversal, I end up at D. So D equals, well, this is equals F up here, I guess. D equals also 98 degrees because D, let's see, we could say corresponding angles are congruent if lines are parallel. Okay, and let's see, last angle here, E. I notice D and E are across from each other, so I'm going to say that E equals 98 degrees because vertical angles are congruent. Okay, and our last diagram, let's see, they tell us that this is 75, and let's just kind of orient ourselves. Here's our two lines, and that are parallel, and here is our transversal. So G and 75 are alternate interior angles, right? So, oops, I'm going to say that G equals 75 degrees because alternate interior angles are congruent if lines are parallel. So they are on alternate sides of the transversal, and interior or inside of those two parallel lines. Okay, so G is 75 degrees. And I noticed that G and H are vertical angles. So H also equals 75 degrees because vertical angles are congruent. All right. Looking at problem 35. For each pair of triangles below, decide if the pair is similar, congruent, or neither. Justify your conclusions using a flowchart. Assume the diagrams are not drawn to scale. Redraw and label the diagrams as needed. Okay, so let's look at A here. Okay, so we know that this is a right angle. We don't know any angles in the second triangle there, but we do know if we have a right triangle and the two legs are 3 and 4, there's a few ways I could find the hypotenuse. One is recognize that I have a Pythagorean triple, and that hypotenuse is going to be 5. I could also use the Pythagorean theorem. All right, so let's see what the ratio is between our sides. Let's see, the smallest sides are 3 and 6, so twice as big. Our second middle sides, 4 and 8, again, a ratio of 2. And that leaves me 5 and 10, again, a ratio of 2. Okay, so we have a side flowchart proof that we can make using the ratio of these sides. So I'm going to say 3 over 6 equals 1/2, and 4 over 8 equals 1/2, and 5 over 10 equals 1/2. All of my ratios are equal, 1/2, 1/2, 1/2. Therefore, I can conclude that, well, they don't give us the angle. So let's say triangle 1 is not equal, similar to triangle 2. Right? And I'm going to draw my arrows in, and my congruence condition or similarity condition that I'm using is side, similarity. All right. Let's look at this triangle here. So what do we notice? This angle and this angle, they tell us, are congruent. They're both 62 degrees. Are there any other angles that I know are congruent? Well, I see some vertical angles here. We will make a little mark. Is that enough? If I have two sets of congruent angles to know that two triangles are similar? It is. We could use angle-angle similarity. So, we're going to have two bubbles. And we could say, let's maybe label these to make our lives easier. A, B, C. And we'll call this D and E. And we could say the measure of angle A is equal to the measure of angle E. And the measure of angle ABC is equal to the measure of angle DCE. Notice we can't just say C because that would be a little bit ambiguous. And we can conclude that triangle ABC is similar to triangle EDC. Notice we don't know if the triangles are congruent, and we'll say this by angle-angle similarity, because we don't know any side lengths, right? So we can't, they might be congruent in this triangle, but we don't know any side lengths to conclude. All we can conclude is that they are similar. All right, problem 36 is solving systems of equations using any method. Show all work and check your solution. If there's no solution, explain why not. All right, so let's start with A here. So three options are graphing, substitution, or elimination. I notice that I already have this first equation solved for y. So it seems like I could pretty easily use substitution here. So I'm going to substitute into the second equation 2x plus 8 in place of the y. Okay, and now I'm going to need to distribute my 2. So I get plus 4x plus 16 equals negative 12. And now we'll combine like terms. Let's see, I have 7x plus 16 equals negative 12. I'll subtract 16 from both sides. I get 7x equals negative 28. Undo the multiplication by dividing, and I get that x equals negative 4. Okay, and once I know the x value, I need to solve for y. So I'll substitute it into my first equation to get that y equals 2 times negative 4 plus 8. So y equals negative 8 plus 8, which is 0. So my solution is negative 4, 0. And I'm going to check by plugging these values into each equation to make sure they give us correct equations, true equations. So 0 equals 2 times negative 4 plus 8. Yep, that's true. Negative 8 plus 8 is 0. And then I could say 3 times negative 4 plus 2 times 0 equals negative 12. Does that work? Let's see, negative 12 plus 0 equals negative 12. Yep, also true. Okay, so we found our solution, and we checked our solution, and we're ready to move on to part B. All right, this is a little bit different. Let's look. We don't have any variables. Here's our x, y, y, x. None are easy to solve for, but as I did that, I noticed, look, here's an x and here's an x. They're not lined up. So I'm going to use elimination for this, and I'm also going to rewrite my equation. 2x minus 5y equals 4, and I'm just going to change the order of the x and the y in my second equation. Right, I just switched those two terms. And I notice, okay, I have a positive 2x and negative 2x here. If I add those two together, I'm going to get, let's see, 0, plus 0 equals 14, which is clearly not true. Right? So what happened? Did I make a mistake? No, what this means is there is no solution. These two lines are parallel to each other, right? I don't know what the exact slope is without doing a little work, but they go on forever and they don't intersect. All right, problem 637. Examine the triangles at right, but here they are below. Solve for x. Redraw and label the diagrams as needed. Okay, so if we just orient ourselves, let's see, this matches that, this matches that, and this matches that. So this side corresponds to 5, and this side corresponds to 4. And I can write my ratio, x plus 5 over 5 equals 10 over 4. And now I can cross multiply. So 4 times x plus 5 equals 5 times 10. So if I distribute my 4x plus 20 equals 50. I'm going to solve for x. 4x equals 30. I'll divide by 4. And I get that x equals 7.5. Moving on to problem 638. Solve the problem below using any method. Show all work. Okay, angle A of triangle ABC. So let's just see. I'm going to start by just labeling. Here's my triangle, ABC. Angle A measures 5 degrees more than 3 times the measure of angle B. Angle C measures 20 degrees less than angle B. Find the measures of A, B, and C. Okay, well, one thing I do know is that A plus B plus C is going to equal 100 degrees, 180 degrees, right? Every triangle, the angles add up to 180. So let's see, it seems like they're giving us everything in terms of angle B. So I'm just going to, so B is here. Let's see, A is 5 more than 3 times B. So I'm going to write A equals, so 3 times B plus 5, right? That's 5 more than 3 times B. And let's see, C is 20 degrees less than B. So it's going to be B minus 20, right? Okay, so I could put everything in terms of B. I could say, let's see, A is 3b plus 5 plus b, and then c is b minus 20. Okay, so let's do like terms here. I've got 3b and a b and a b, so that's 5b, and then I have 5 minus 20 is negative 15 equals 180. So I'll add 15. 5b equals 195. And then I'll undo the multiplying by dividing to get 39. 195 divided by 5 is 39. Okay, so if b equals 39, I know, let's see, what is a? A is 3 times 39 plus 5. All right, 3 times 39 is 117 plus 5 is 122. This is all in degrees. And c is 39 minus 20, so 19 degrees. So those would be my 3 answers. And let's just check, do they add up to 180? Let's see, 39 plus 19 is 58 plus 122. Yep, we're good.